Hello, folks. Thanks for joining. We'll be getting the webinar started in just a few here. Okay, I'll go ahead and get started on things here this morning. Again, hello everybody. Thanks for joining today. My name's Brian Jones, Customer Success Manager with EDX Wireless. And today we're going to show you some tips, tricks, and best practices for 5G planning with EDX SignalPro using our 5G module. And we're going to particularly focus on CBRS as a use case. And because CBRS can be either 4G LTE or 5G, I've got both LTE and 5G projects open to take a look at and kind of jump back and forth between a few different topics. As Kevin said in the chat, he'll be keeping a watch on the chat window. If you do have any questions, please reach out through that chat window, and Kevin will do his best to answer those questions, or we'll reach back out to you after the webinar. I've got a couple more than my usual, 8 slides or so that I have for these. So I do want to sort of jump right into it. I'm going to try not to take us all the way to the top of the hour and certainly not go over. But we'll go ahead and jump right in here because there's potentially a lot of ground to cover. So, jumping into specifically 5G planning and CBRS planning in the mid band, one thing that I wanted to make you aware of right up front it's been implemented in Signal Pro for a little while, but I haven't seen too many folks using it yet. And I wanted to point out that we have implemented a propagation model specifically from the 3GPP forum for use in 5G. And it's really worth mentioning that this is equally applicable as a propagation model to 5G or 4G use cases, or really any mid and high band technology, even if you're not using a 3GPP technology, it's perfectly possible to use this propagation model in your SignalPro project, and it addresses a wide range of frequency bands. The model is called the 3GPP Empirical 5G, and this model is really designed to be used with terrain elevation data, but not necessarily land use, land cover, or in other words, clutter data. So this model is really ideal in a couple of different situations. The first one, if you take a look at the land use, land cover data that you do have for a given area, and maybe it's out of date because this is a brand new subdivision that's going in, or maybe you find something about the land use, land cover that's not accurate for that particular area. Um, then in this case, switching to the 3GPP empirical model can give you a way to have reasonable results that are going to take into account potential losses from clutter and foliage and things like that that you may not feel can be represented accurately enough in your clutter data to use a more standard approach like our Anderson 2D with one of the different clutter loss options turned on. And the unique thing about this model as compared to another empirical model, for example, like Okamura Hata or Hata Extended, one of these, is that the 3GPP model takes the terrain path profile into account. And I'll go ahead and jump over here to a very simple LTE based project that I've set up here. And I've run this area coverage result. I guess first I'll go ahead and show you the terrain that we're working with here. And you'll see I've got my site located up on a hilltop, looking out at the valley around it. So I've got a pretty good site location here, but I'm actually not using any land use, land cover data in the propagation results. Of course, EDX offers land use, land cover data in a variety of different resolutions. So if I have that and I feel like maybe it's just not high enough resolution for this scenario, or again, if I discover that it's out of date, or in a lot of situations, folks, especially internationally, may have clutter data that they already have from another project or were able to source, but it's not at a very high resolution. If you are doing a mid-band case, I recommend either having very detailed land use, land cover data, ideally with clutter heights, or in the absence of that, again, we can go in and configure that 3GPP empirical 5G model. And that's in the standard model category. It's down right next to the bottom of the list here. And if I go into supplemental data, here's where I can choose which use case I want to apply for this. And so I've chosen the urban macro because we do have some urban area to serve in this case, but my site is located up on a hill and has a good view shed around it before there's any clutter. Uh, this preview chart that you see on the right-hand side, this will show us, let's say I go ahead and put my 3.6 gigahertz frequency band in here and my station height of 30 meters. This will show the path loss curve that gets used for both line of sight and non-line of sight conditions. And the empirical model works that out using the terrain elevation data and doing a specific path calculation to each location. Again, this is different from HADA type empirical models and some, for example, ITUR models and things like that, because we are looking in a detailed way at the terrain and not at a height above average terrain as a HADA model would use. And so you can see the effects of that really clearly in my model here. On the far side of this hill, I have very poor coverage, even though it's very, very close to the site. if we were looking at like a HADA extended model or another just simply distance-based empirical model, we wouldn't see this sort of detailed shadowing. And you'll notice as we get out sort of into the flat terrain here, we have a very uniform result that's basically mostly influenced by the antenna pattern here. So again, if you do have detailed high resolution clutter data for your project area, then you may really get better results and more, I would say more precise, more accurate results from the Anderson 2D with one of our clutter loss options turned on. But I wanted to show this model to you because it's usable in situations where you don't have that clutter data, or if you want to create results that are reasonably conservative results and based on that 3GPP standard. For example, if you're doing just initial RFP design work and you don't really have a lot of details about the environment yet and you haven't done a site survey, then this model may be a good way to get a quick back of the napkin result that's that's still taking terrain elevation and hills into account, especially if you have a hilly area or a mountainous area that you're planning for. I think this is a much, much better choice than HADA Extended or any of those propagation models. While I'm on the topic of propagation models, you can see my more standard model for doing this type of planning is still the Anderson 2D. And very often for non-line of sight use cases, I'm going to use the add clutter pass-through loss, which is going to apply clutter loss in dB per kilometer that path is propagating through a particular clutter type, through the actual height of that clutter type. But what I want to show you is the ability to now adjust how much terrain shadowing you'll get. So if I'm using polygon building data, or if I've got a highly reflective terrain environment, if there are a lot of canyons and a lot of sheer terrain with rock that's reflecting signal, and I'm seeing sort of better propagation conditions than I normally would in non-line of sight behind terrain. For the Anderson 2D model, we can go into supplemental data in the latest release of the software, and we can adjust how much diffraction loss we get for either terrain obstructions along the path or for building obstructions along the path. And buildings, especially if we're in a dense urban scenario and using polygon, 3D polygon building data, sometimes the over the top building diffraction loss for the path propagating over the top of the building can be too pessimistic for that sort of use case if we're in an urban canyon. And so in that case, I might reduce this building diffraction loss to something smaller in order to get less severe shadows behind the buildings. And the great thing about this is that I can do that independently so that I can adjust how much loss I'm getting behind buildings without touching how much loss I get for an actual hilltop or terrain. So with those propagation model options, really you have a way to do initial quick RFP response work without having to dig too deep into your land use clutter and adjusting heights and that sort of thing. But of course, if you do have that good high resolution land use, land clutter data, and especially if you're using clutter height data, then it's great to leverage that data in the propagation model. And of course, with our tuning options here, we can always go in and bring in real field measurement data to adjust how much clutter loss we're getting and really get the tightest correlation between our prediction results and field behavior. So I wanted to call that out as a new option. Um, and also point out, just so I don't forget, there is a user-defined breakpoint model included as part of that. So if you've gone out and done field measurements and you have your own sort of line of sight and non-line of sight curves for loss, you can actually plug those in fairly directly here. You can create a model based on that. Uh, Again, this may not fit every use case, and certainly if you have high resolution data, I recommend using it, but I wanted to show that model to everybody. One other feature before I dive specifically into the 5G and LTE feature sets, this applies to all of SignalPro. When you are running an area study, whether it's a basic area study or an LTE or a 5G area study, you can now select more than one mobile remote unit at a time to use for setting up that study. And as you can see in this example here, I've set up a mobile remote to represent distribution automation switches up on the top of utility poles. And then I've created another for a mobile device walking around right down at street level. And so I'll go ahead and jump into my 5G project and show you what this looks like. I set up my area study with both of those UE types. Oh, I guess in this one I did a pull top UE at a 6 meter height. And in this case, I'm using the 5G study group and I've set up an RSRP study. And so that's the area study that we're seeing on the map here. But if I expand this in my area studies list, because I selected both of those mobile remote units, I can easily and quickly switch back and forth between here's what my RSRP is going to look like for street level coverage walking around, and I can see that I've got some problematic areas where I may have poor performance or no performance at all versus if I run an area study for or if I look at the pole top UEs, then most of my service territory is covered pretty well with just a few holes in here. Um, it's worth saying that when you go and run the study queries, it will query against the one that is active. So you'll want to make sure when you run your study query, you've got the correct area study active. So far, we're getting great feedback on this feature. Very often, folks were having to make multiple copies of the same study in order to represent different mobile remote situations. And now you can just create the study once. And of course, if I've got a color profile for that study, I don't need to set up my colors and signal levels every time. Once I've done it once, I can save that color profile as a file. And in any of my other projects, I can just go ahead and import that color profile. So I've got one here called rsrp.xml. I could import that XML file into any project where I've set up an RSRP study, and it's automatically going to use this color scheme that I've set up here. So a great little time saver there. And again, that applies to any area study that you might want to set up. And those color profiles apply also to route studies and multi-point studies. So you can save yourself some time in picking those colors out and picking out the signal levels that you're working with. Okay, on to an overview of the actual 5G module and the feature set that we're including in there. Down on the lower right hand side here, you can see the area study list that we've got so far for the 5G module. This study list is growing. We've got active development going on our 5G module and the features contained in there. And I'll tell you a little bit at the end about sort of the features that are coming soon, right around the corner. And in addition to that list of different performance criteria studies, which can be run as area studies or multi-point or route studies, of course, we've got propagation models, as I just showed you, that are appropriate for these use cases, both for outdoor, indoor, and mixed use cases. And I would really urge you, if you are working with an indoor or an outdoor to indoor sort of mixed use case, please do reach out to us either through the support portal or through your sales engineer. Let us know what you're doing, and let's set up a customer success session to talk about how you can best set up your model to give you good, reliable results and make for a nice workable project. Uh, Automatic site selection comes with that 5G module. So in other words, you can input all of your potential locations to place a G node B, or if we're talking about LTE, an E node B. And that list of locations can include differing heights and even different cost factors for the towers. And we can try to select you the best overall solution to meet the performance criteria that you're looking for. We have automated PCI code planning, automated neighbor lists, and we can support carrier aggregation. If you're using the CBRS band and maybe a private LTE band or a private 5G spectrum, we can aggregate that data rate together. And you can see with our maximum aggregated downlink throughput, you can find out what the actual deliverable data rate to that remote is going to be. So let's look in a little bit more detail at some of those features and maybe just kind of go over the workflow for setting up a 5G project. And again, this is going to be very, very similar to LTE. If you're already using our LTE module, I encourage you to use the LTE Pro feature set, and you'll find that if you familiarized yourself with that LTE Pro feature set, almost nothing will be different in the 5G feature set. So you'll be able to jump right into 5G and make comparisons between the two technologies and not have a whole new learning curve. Um, so of course, the first step, once I've set up my basic project, including terrain and clutter and buildings, and got my propagation model configured. The next thing is to set up my equipment definitions, and we can set up templates for what our G Node B looks like. And we can also set up mobile remote units or CPEs to represent our UEs. Um, a couple things to bear in mind when you're setting up the G Node B, and I'll skip over to my example project for 5G here. Um, just like any SignalPro base station, you can have more than one sector on the site location, and each one of those sectors is going to have an assignment for system name and type, and also an assignment for MIMO and adaptive antennas. In this case, I want to go ahead and select 5G from the list. If you are doing 4G CBRS, make sure and select LTE Pro instead, and then go and set up those technology profiles under the appropriate module. And then for the MIMO adaptive antennas, I've chosen a pretty mild MIMO B 2x2 here. Bear in mind that we can support custom MIMO configurations. If you've got a really fancy uh, MIMO array on the base station and or on the UE, under these user-defined categories, you can select any of the different MIMO types and antenna configurations, and you can plug in whatever numbers you need in this table to show interference mitigation or to show an increased throughput based on that MIMO. And that should be able to get you to the data rates that you expect to see under given performance levels. Um, So that covers the technology here. We want to make sure that also when we go into the receive parameters for the sector or for the G node B, we want to make sure and set up the bandwidth to be equivalent to what we're using for that CBRS band. In this case, I've gone with a 20 megahertz channel. and I've checked on the use load-based noise rise. Now, this will, depending on the traffic load that's predicted on the sector, this will introduce the recommended amount of noise rise to go with that traffic level, and that'll be rolled into your RSRQ study, your SNR, and data rates. Bear in mind that that is also available on the mobile remote unit here. I've got use load-based noise rise, which okay, it's turned on for my main UE here to use that load-based noise rise. And again, I've set my bandwidth here. The other things that you want to make sure and set up, if you're using LTE Pro, make sure and turn on this Use UE category. And in this case, I've selected a Category 5 UE. And what that does is limit the amount of data rate that can be applied to the mobile remote unit. So, for example, if I go in here to my traffic modeling, I can see some limits on my different UE types here based on that category, and that'll limit how much traffic they can demand. Um, in my 5G project here, I'm still modeling the highest deliverable data rate for the QCI level and the signal to noise ratio that's been calculated. Let's see, make sure I don't overlook anything. The carrier aggregation codes. You can see here, if I do have maybe a CBRS band and another bit of private spectrum I'm using, I can switch on this use CA configurations and put in the code. And this comes from the 3GPP standard, these carrier aggregation codes. You'll put in, the appropriate code associated with your UE to say what bands that can decode simultaneously. This should be in the standard, and it should also be in the specs for the particular UE equipment that you're looking at. So it should be in your equipment spec sheets. And please do reach out to us if you're having a hard time working out which UE category you should use or which carrier aggregation code you should use. Okay, once we have set up our sites and our templates to use either the 5G module or the LTE Pro module, then we want to go ahead and set up what that means. We want to set up our technology profiles. And so I'll jump back to my 5G project here and show you how that goes. If I go into 5G networks and technology profiles, uh, these the band number here, this is where I select you'll notice I've got a default technology type, and this is where I select the frequency band that I'm going to be using. CBRS is N48, and so I've selected that one. And once you select this band, the other options populated into the table there are pulled from the standard. So I have some options here as far as subcarrier spacing. I have the different options available for bandwidth. And of course, I've chosen 20 megahertz because that's what I've got in my receiver definitions as well. And if I'm using the extended guard band, or if I'm allowed to use the extended guard band, in LTE 4G, I believe you are for CBRS, but in 5G, it's not there. Then I can set up that guard band as well. In this case, just to have another technology that I'm showing you, I've gone ahead and set up also a piece of N77 spectrum at 10 megahertz, and that's a TDD band. Just making sure I'm not skipping over anything. Okay, with the sectors list and the channels info. Okay, I'm gonna jump over to LTE just to show you, if I go into LTE Pro technology profiles, I've got the exact same options here. I choose band 48, and it's not N48 because it's just 4G. and I've got a slightly shorter list of available bandwidths, and there's my extended guard band if I want to use it for 4G. Uh, let's see. Oh, the other thing I guess I should show is that either of these two columns here for the TDD or FDD, that will be selected based on the band. So if the band is just a frequency division duplexing band, it'll just show FDD there, and it'll use the appropriate pieces of spectrum for that. If it's TDD, I have the ability to select a frame configuration. So here under TDD slot configuration, I've got all the different slot configurations that I can use from the standard. And same goes for my special slot configuration here. Um, so this is information that you'll want to get from the specs on the particular equipment that you're using in that deployment. This gives a very downlink heavy frame configuration. So this would be typical for something like fixed wireless access or a solution where I'm trying to provide a lot of downlink data to my UEs. If this was, for example, security cameras, that frame configuration might be exactly the other way around, where we've got a whole bunch of uplink slots in order to get that data back from the UE, and we need fewer downlink slots for downlink data. So again, it's important to take a look at the specs for the actual equipment solution that you're going with, and go in and choose the appropriate configuration there. Um, the channels info, if I go into, again, LTE Pro, because this is LTE, and channels info, or I guess I should say, I should point out the sectors first. Once I have set up my technology profiles, I can assign those technologies to the sectors in my project. And if I only set up one technology profile, then of course it's just going to automatically populate these. As soon as I chose the LTE Pro system type, it populated it with the default LTE Pro technology profile. If you have more than one, let's say I was supporting both band 48 and band 77, I would want to create 6 sectors in my project, and those other 3 sectors I would maybe assign to the band 77, or whatever the situation was. Channels info, if I go into there, here's where we give some parameters that, again, are going to be based on the particular equipment solution that you've gone with. Most importantly, there's the is it reference subcarrier? I think it is. The subcarrier EPRE, or the power used per subcarrier here. And this will be different by technology solution, and also by whether we're looking at 4G or 5G. The 5G RS EPRE is lower than it is for 4G. And then different technology solutions may have different power offsets for each of these different categories, and a different overhead percentage. And of course, we can run these at different nominal cell loads. So you'll want to look those up from the spec sheets in case there's something that's not just going to be a default offset like we've got in here. So once I have configured those values about the technology profiles themselves and set up any offsets that I might have, here's where I might want to go in and actually select which tower locations I want to use for serving this area or this group of point to multi-point subscribers. And I won't go into a full demo of this. There is a great knowledge base article. If you go in through the support portal and look at our knowledge base, There's a great article on automatic site selection that'll take you step by step on how to use that feature. And a lot of our users for a variety of technologies are leveraging this feature and getting great results from it. Um, Again, just to show you how this is set up, first we would go into our databases, towers, and poles, and I don't have a tower database yet. I can either import those candidate pole locations from just a CSV file or from a Google Earth KML if somebody sent me a bunch of push pins. Uh, and I can create a height as well as a relative cost for each of those pole locations. If I don't know where the polls are going to be and I'm trying to do an RFP response that's reasonable, we also have some tools over here where I can create candidate locations either based on just sort of a uniform grid. I could say, okay, well, give me a candidate poll every 100 meters. Or better still, I could say, okay, create some poles along the streets. Maybe utility poles or streetlights are up for grabs as a G Node B location. I can create some candidate poles along the streets, and that way, when the automatic site selection runs, it's going to use candidates that are distributed along the streets instead of just randomly in a grid across the area. Um, and of course, I can create a bounding file here to filter that list of points down to just my area of interest. And the great news about this is you can import thousands or tens of thousands of candidate locations in that towers and poles list. And the automatic site selection, which I would find here under network design analysis, either auto placement for areas, if I'm trying to cover the entire area in a mobile or nomadic scenario, or if I have fixed subscriber locations, like you see here, I've got some fixed point to multi-point CPE locations. If I only care about serving those fixed locations, then I can go in under multi-point and backhaul networks, create hub and transmitter group, and I can use that same automatic site selection feature to choose an efficient collection of sites to cover those multi-point subscribers. And I've included here a couple screenshots from other projects of what that automatic site selection looks like. Once I've completed the run for that selection, you can see a mode here where it's showing you all of the towers that it's selected. And you can go into a toggle mode and turn them on and off and see what would be covered or not covered. And you can also see for each proposed tower, you can see either how many fixed subscriber locations it's serving or how much overall area it's serving. And when I'm happy with that solution, I can just go ahead and click yes, and it'll create that transmitter group based on my site template and create all those sites into my project. This coverage graph that you have access to once you have run the automatic site placement, you can bring this graph up to show you essentially how many sites it will take to cover what percentage of the area. And there's always a diminishing returns effect that's based on the terrain and the clutter morphology in that particular market area, where just to use this chart as an example, it takes about 4 sites to cover 90% of the area in the example that I used. Getting up to 95% or better might take twice as many sites, and getting up to something approaching 100% of the area might be completely impossible with the candidates that you've got, or it might just take a huge number of sites. And so this is a great graphic, a great deliverable. Here, I'll just temporarily, I'll make this bigger in case you can't see it very well. This is a great deliverable if you've got customers that you're trying to show them what is possible given a certain budget. You know, if you want to tell them, look, we can cover 90% of the area with just 4 sites, But if you want 95% coverage, maybe it'll take us 8 sites. If you want 99% coverage, it might take 15 or 16 sites. And that sort of that curve of diminishing returns is really going to vary from project to project and depending on what candidates are available. So this automatic site selection feature can not only propose an efficient collection of sites, but it can also help you understand that curve and how difficult it might be to get to 99 or 100% coverage of an area. Make that back smaller again. So, however you get your sites onto the map and into your project, whether you use the automatic site selection feature or you go ahead and import those through the spreadsheet editor, or even just place them by hand on the map, once you have those sites, you're going to want to run the PCI code planning and the neighbor list function because those are important deliverables for either an LTE project or a 5G project. And so I'll go ahead and show you those features in the 5G real quick. If I go up to, you'll notice I've got 4 sectored sites in each of these. So each sector is going to need a PCI code, and we'll need a neighbor list for all of that. If I go up to 5G PCI planning, here's where we've got in the conflicts area. I can set up different targets for what is the threshold that I'm looking for to avoid different types of confusion, and also how heavily I want to weight those types of conflicts in the scenario. By default, the default numbers that are in here are sort of standard for from the 3GPP standard and standard for this type of planning. But if you're particularly trying to avoid one type of confusion or the mod 3 conflicts or what have you, you could assign a heavier weight, or you could even assign a higher threshold. Um, the other piece that's important is if you have a neighboring network or another network that may share some of the coverage area. For CBRS, this is a particularly common expected use case. Um, CBRS is a band where if you're operating a CBRS network for one county, the neighboring county may also be using the CBRS spectrum, or even another agency within the same county might be using the same CBRS spectrum. And if you can coordinate with them on your PCI codes, then they can furnish you with a list of what PCI codes they're using in their network. And if you plug those in as excluded PCI codes, then when you run this planning, it will avoid using those PCI codes so that you and your neighbor won't be having frame conflicts and won't be causing errors in each other's network. Um, that's some place where even if they're not using SignalPro as a planning tool, just sharing those PCI codes that you're using back and forth with other neighboring or other incumbent CBRS networks could really have a positive outcome in helping you maximize the performance for the amount of spectrum that's available. Um, and mostly this is going to come into play in the edges of your network, right, where two networks butt up against each other. I also want to show in here we have a transmitter group selection for the unlocked group versus the all sectors group. And this is meant to support expanding an existing network. If I've already got a bunch of sites deployed out there in the field, and I've already set their PCI codes and already optimized their antennas and all of that sort of thing, I don't necessarily want to change that just because I'm adding a few more G node Bs for maybe there's a new residential subdivision I'm trying to support or something like that. So what you can do is create transmitter groups for the existing sites and for proposed new sites. And if I set my existing group to the all sectors group, or I guess I would want to set the all sectors group to be the master group, and then the unlocked group, I would only put the proposed sector group there. And when I go ahead and run the PCI code planning function, it's going to treat the existing all sectors PCI codes, anything that's not in the unlocked group, it's going to say, okay, those PCI codes are set and they're locked in place, and we're only going to choose PCIs for those members of the unlocked group that will not conflict with members of the all sectors group. So I would go ahead and run that, and it will propose PCI, PSS, and SSS codes that I can then go ahead and click apply to keep those, and it'll go ahead and apply those in the list here. And then I can just go ahead and click accept in order to keep those PCI configurations. The next thing up would be neighbor lists. And here's where I can put in the RSRP threshold and the maximum distance in order to consider two sectors as neighbors. And from there, then I can just simply, it works in the same way here. I've got an unlocked group and an all sectors group. And I would just simply run this and it'll create that neighbor list for me, which I can then hit apply and accept. And now I've got a completed neighbor list. Um, it's just about as simple as that. I can, if I want to, I can zoom in here and I can show my map in the background so that I can see, well, where are those overlaps? What does that look like? Um, and I've got just so we don't have to watch anything compute here, you can see I've got a screenshot of the existing matrix here, or the completed matrix and what this neighbor list will look like when it's done. Moving on, because I see I'm a little bit short on time. We've got about 15 minutes. Um, I'd like to talk really quickly about supporting area-wide versus multi-point planning, particularly area-wide and multi-point. If I jump into my project here, um, let me go ahead and I will hide my multi-point results. Um, if I'm just doing area-wide studies, and that's area-wide, if you're not real familiar with SignalPro, that's what we call these heat map type studies that you see on the screen here, where I have set up a study grid. When I define my study grid, I say, okay, I want a grid point every 5 meters in the grid, and you can see the resolution I've got for the chosen area. And at each of those grid points, we assume a uniform mobile remote or a uniform UE at that location. So if I go into mobile remote units, here's where I've set up the different UE types. Again, I've got a UE mounted up on the top of a utility pole. And I've also got, just for a basis for comparison, I've got one sitting down at street level at 1 meter above the ground. You can apply different antenna patterns to these. You can apply different amounts of potentially body loss. If we're down walking around on the street, we might want to include 5 or 6 dB of body loss for the potential that the UE is in its user's shadow, effectively. Um, and when I run the study, again, when I set up my study, I can choose which of these UEs or which of these mobile remotes I want to use for the study. And that'll allow me to switch back and forth real quickly between the coverage, the area coverage for one versus the other. But let's say we've got a bunch of fixed subscriber locations, each of which may have a different equipment configuration and a different height above ground level. If we're looking at a fixed network like that, then we really want to do a direct path prediction to each one of those fixed locations. And that's where the CPE or customer premise equipment item comes in. And if I go into CPE types here, I can set up as many different types of fixed subscriber devices I want and then populate those onto the map, either just by, placing them by hand, or much more often, you're going to want to go into the spreadsheet editor, go to CPE data, and say, okay, here are the IDs, lats, and longs for each of these CPEs. And whichever template I'll choose, it'll put that type of equipment at that location. Um, in order to then run a study for those fixed CPEs, we would set up any of the same study types. So anything we can do as an area study heat map, we can also do as a fixed point to multi-point here. So I can do my RSRP, downlink throughput, etc., but on a fixed basis. And so instead of a generic UE that might be moving around anywhere within these grid cells, for our fixed subscriber locations, when we run that multi-point study, here I'll turn off my area study. These little colored dots that we see here are for a direct path profile to that precise location, including differences in its height, differences in the equipment configuration, and so forth. Um, I can also show with my CPE to hub links layer, I can show that. And the one thing I also want to point out is maybe you don't want the study to automatically calculate the strongest server. If I've got a directional antenna on the subscriber and I've pointed that at a particular base station, then I might want to set that base station as the parent, regardless of what the prediction shows. If I want to do that, I can go back into my spreadsheet editor here, and over here at the far right-hand side, you can plug in a sector ID to explicitly assign that CPE to that sector. And if you've done that, you'll want to go into the multi-point studies list. I'm doing that just by double clicking here. And I would use the assigned server instead of use the strongest server for my study results. Um, that one sometimes generates confusion for people because they'll set up a multi-point study and use assigned server, but then none of the CPEs have an assignment, and so nothing gets any results, and they get confused. So just remember, if you want it to automatically find and set the strongest server, just choose that option here. If you're going to plug in your own assignments, do that through the CPE data spreadsheet and then use the assigned server option here. Uh, Finally, the other option that we have is a route-based study. And I just realized I haven't set one of these up. So I'm just going to real quick here draw a polyline to maybe represent this road. And I'll go around the corner here on this road and go to there. So if I want to show real precise coverage along, let's say, a highway corridor or a particular road, a railway, something like that, I can set up or import a line to represent that route, and then go into route studies, choose that route line. Oh, see, now I have to find my project. Okay, this is Tucson CBRS. Route 1, and I'll say, okay, I want a study point every 10 meters along that route. And then I can add a study for my 5G RSRP. I'm going to use that color profile again. See, I don't like these colors at all. So I'm going to go import color profile, RSRP, and presto, I've got the same color assignment that I have for all my other RSRP studies in this project. And then if I run that route study, oh, good, it's not going to take too long. I had to be careful not to choose too huge a route. Now I've got those RSRP values along this route. And if I want to, I can hold down R and select a portion of this route and display those RSRP values along the route here. So I've got some fluctuation up and down, but nothing's falling below negative 100. So I'm in good shape with that route study. Um, any of these three study types are they're running the study results in essentially the same way, but the route studies and multi-point studies allow you to use a much finer precision where we're not just calculating something to the middle of a grid cell, but we're calculating to the exact lat long that you've specified. The last thing I'll say about route studies is, hey, these can support either terrestrial routes or airborne routes. If you're looking at drone flight paths for power line inspection or for facility inspection, and you want to guarantee 5G coverage along those flight paths, or look at 5G performance along those flight paths, that route that I created can include elevations, and I can make that a flight plan that flies along at an elevation that is decoupled from the terrain. Um, and we've got some folks taking advantage of that, both for 3GPP technologies as well as other technologies. This would apply to really any technology, any frequency band. You could do the same thing with route studies. Oh, the last thing that I wanted to show is if I've already set up my mobile remote units and I just want a copy of that for fixed subscribers, I don't necessarily have to go into the CPE types dialog and populate all the same information over again. I can just set up my mobile remote unit and then choose which CPE type I want to set or I want to copy that to. And this copy to CPE type button will automatically move all of these parameters over to the appropriate CPE type. And that's just a time-saving feature for you. Okay, it looks like I'm going to make it across the finish line before the top of the hour here. Coming soon, we have new traffic modeling features that are going to be implemented into the software quite soon. What I'll show you right now is the traffic modeling that you'll see in your release version of the software today. If I go to network design analysis, traffic modeling for 3GPP traffic loading, and so that's going to include 4G, 5G, NB-IoT, LTE-M, any of those 3GPP based technologies, we would use this dialog for. If you're using something else, a proprietary like a Cambium or a Tirana or something like that, you would use the non 3GPP traffic loading. But in this case here, in the 3GPP, what we're going to do is choose the transmitter group that we want to load a predicted traffic level onto, choose a polygon file if we've got a particular service territory that we're interested in, and we can set up either a uniform number of users per square kilometer, or we can set it up based on the clutter. I can say, the residential clutter type has so many users per square kilometer, whereas the urban clutter type has maybe more users per square kilometer. And you'll see in for each of my different UE types or each of my different mobile remotes that I've set up, I've got max data rates as given by the UE category that I selected. And then I've got a data demand, and this should be the average demand level for uh, a user of that type. We can also do percentage of traffic carried so that if some of this traffic is going to be carried by another network, another TX group, etc., you can configure that here. In the simple case, this will always be 100%. And basically, I'm just going to populate the number of users I want per square kilometer and hit generate traffic. And that's going to give me a predicted traffic load to use on the cell, which again is going to impact the study results by creating potentially some noise rise. If I have a cell that's at 60% of its potential traffic load, then I'm getting to get something like 4 dB of noise rise. Well, exactly 4 dB of noise rise. Um, so if you're loading traffic in your projects for the moment, you can go ahead and use that function. This is about to be improved in a number of ways. We're going to be including the ability to apply both mobile and multi-point traffic, as well as for AMI 2.0, we're looking at applying mesh traffic and including that as part of the prediction. And then I'll jump back to my slides here. In order to model different service types, where maybe I've got some fixed machine to machine type UEs, and then I've also got people walking around with their cell phone, those are going to imply different service types, and those different service types might use different bearers in order to accurately predict how that traffic will get prioritized and how it'll get delivered to the UEs. We're implementing a services section and a bearers section here that really quickly, the bearers section allows you to customize the QCI tables, set priorities, and which QCIs are guaranteed or not. And then the services section, here's where I can, for example, create a voice over LTE service name, choose the bearers that are going to support that, and set um, the average required throughput that a user of that service type is going to require. And we'll have a way to assign those service types to specific UEs. And that'll give us a little bit more detailed way to assign static traffic to the sectors. But we're also, of course, working on the Monte Carlo analysis here, or rather, I should say, we're updating the Monte Carlo analysis to support the prioritization of traffic and look at how the demand level and how the loading on the cells will change as users are moving around in the network and traffic demands are changing. So stay tuned for the updated traffic and capacity planning features. I'm sure we'll do another webinar on that. And if you again, if you have a 5G or an LTE project that you're working on and you have any questions, please don't hesitate to reach out through our support team or through your sales engineer to set up a customer success session, and we can make sure that you're set up to use the feature set we have today effectively and understand how that feature set is going to change in the future. Uh, with that, we're right at the top of the hour. I thank you again for tuning in today and hanging with me through that sort of race through the feature set. Um, if there are any questions that Kevin hasn't already addressed in the chat, we'll follow up with you after the fact, and I'll let you all go so I'm not going over. Have a great day.